Let's start with the topic. So CANopen FD, let's have an eye on the current status and the future of CANopen FD. Briefly, at the beginning, some words to my person and to Canon Automation. So my name is Reiner Zitzmann. I'm the General Manager of Canon Automation, located in Nuremberg in Germany. And I have long experience in CAN-based networking, conformance testing, interoperability testing, writing CANopen specifications, and so on. And since 2017, I'm General Manager of the Canon Automation GmbH. Furthermore, I represent Canon Automation in several standardization groups. So, for example, in that group, standardizing the communication accompanying a charging process for light electric vehicles, or I'm an expert in the TC9WG43 working group that standardizes the communication in rail vehicles. Similar group that exists on European level for standardization of the communication in garbage trucks. And of course, we have several standardization mirror groups where I represent the interests of Canon Automation members. Canon Automation GmbH is a 100% daughter company of Canon Automation Association that had been founded in 1992. The association had been founded in order to support the widespread of CAN, of the controller area network. The CAN had been developed for special regard to use in automotive industry, so in cars. This group here funded said, why to limit the CAN, which is a rather robust, flexible, highly available and reliable communication mean? Why limiting the use case to the cars? Why not using the CAN in other application fields? And so Canon Automation tries to inform people about latest developments in CAN, about the attributes of CAN, and in addition, it tries to support the users of CAN. So we have established since 1992 a huge social network, and if you are working with CAN, if you're facing some challenges in CAN, then one good idea could be come to Canon Automation and we try to assist you, we try to help you further. Maybe we can do it directly, but maybe we can, or of course we can rely on our huge network that we have already established, and we can therefore find some SEER members that are specialized in your topics and can assist you so that you can accelerate with your project. Canon Automation is located in Nuremberg, so in South Germany, Bavaria, and you'll see here our contact details. So it's rather easy to contact us by phone, email, or that's not on this slide, but on the last slide, I think, via our social media channels. Briefly, very briefly, to the history of Canon Automation. So Canon Automation funded, as I said, in 1992. And since these days, Mr. Holger Seltwanger is the managing director of Canon Automation Association. Canon Automation tries to make people aware of CAN, to raise the awareness of CAN, to assist people in using CAN. And to be very brief here, and to focus on the topic, the CANopen protocol, after its development in 1994, 1995, had been handed over to Canon Automation for maintenance and further development. So we see here the first release of a version that is now known as CANopen and maintained at Canon Automation, the document number CR301. This is or had been released in 1994 in November, and we did some further maintenance, and Bosch used the International CAN Conference in 2012 for presenting an improved CAN. It had been the CAN with flexible data rate. And this CAN with flexible data rate provides us with a higher data throughput. And we have here a working group now, it's the interest group CANopen FD, that thought now, how can we make use of the attributes provided now by CANFD from the perspective of a higher layer protocol such as CANopen. And the result was then the document CR 1301, the CANopen FD, and this we will discuss today. Furthermore, we see here the history of CAN has not been written yet, so there's still work ongoing. I'm coming now from a meeting with about 40 members where they discuss the future of CAN. There's the CAN XL project where they evaluate how can we tunnel, for example, Ethernet frames via the CAN, and how can we carry up to 2000 byte of data in one CAN frame. So if you're interested in these things, then I'd like to invite you to join the CAN Automation Association and to join these groups and to bring your input. CAN Automation is a members-based association starting in 1992 with 16 members. So we have more or less constant growth, and in 2020 we have now, or had at the beginning of the year, 670 member companies. So now we have a very specific situation with this corona, but nevertheless, we succeeded also during this year to increase further our membership. Nowadays we are around 700 CA member companies, paying members. So if you want to see the details, please visit our website. There you can see from which country our members are and which are our members. Well, what are these members doing? They do some technical work, they do some marketing work. So our technical work controlled by a steering committee, the so-called technical committee, runs these 6 interest groups dealing with CANopen, also dealing with CANopen FD, the IG CANopen FD, which is now focusing on evaluating how can we benefit from CANFD from the perspective of the higher layer protocol CANopen. And we have also a working group J9039, which is on the one hand accompanying the mapping of J9039 to CANFD at the SIE. On the other hand, they are developing some own documents dealing, for example, with the question how to tunnel CANopen information via J9039 networks. And independently which communication interface we support, it would be very beneficial for device designers if the data arrangement within the devices could be rather similar, and therefore we have a more or less bus independent working group, the IG profiles, organizing how a device should maintain data device internally and how to provide it on the communication interface. And this information we can map then to the corresponding communication medium. We have an IG lower layers, it's now called on this slide. We have the old name IG layer 1 and 2. It's now called IG lower layers. And in this working group, we are working on the future of CAN. So for example, we have here a SIG CAN XL, which is defining how could the next generation of CAN look like. We have there at the moment, it's not now on the slide here, it's a working group that is called SIG CAN FD Lite, which is defining a low performance CAN FD network optimized for the usage of light control. We have there some further working groups thinking about signal improvement and these things. So a very interesting working group. And finally, we have also a working group that deals with safety and security issues. We have there a very young task force now established that is dealing with bus line redundancy in an independent way from the used higher layer protocol. So if you think there's something interested, once again, I'd like to invite you, join the group as a guest and think whether it's beneficial being part of this group and of the social network provided by CAN Automation. Furthermore, CAN Automation is doing some marketing. So we see this here. We run at the moment 3 marketing groups, one for CANopen FD, one for CANopen Lift Control, and a final one for municipal vehicles, mainly focused on garbage truck applications. And here in these groups, companies come together and evaluate which are relevant exhibitions, fairs, where CAN Automation should exhibit and should present to the attendee of these fairs, to the visitors, why it is a good choice in this market to opt for a CAN-based, respectively CANopen-based solution. So you see, the work of or the development and maintenance of CAN automation specifications is a major part of our work here at CAN Automation Office. Additionally, we do now some marketing for these specifications. We try to raise awareness of that, what had been specified in these documents. Furthermore, we try to provide some arguments why it is reasonable to opt for a CAN-based or CANopen-based solution in a specific market. On the other hand, we try to assist people in implementing CANopen from the perspective of a device designer or system designer. Finally, we offer also testing services, either device testing for CANopen. On the other hand, we try to offer interoperability testing, so-called plugfests, that people can meet and can evaluate as a device designer. What would a system integrator experience if he plugs together all these devices, and would he experience a certain degree of plug and play behavior, or are there some showstoppers which have to be removed? With regard to CANopen FD, we are talking about now, we have a testing procedure, so CANopen FD devices have to be tested. And in the meantime, till we have proper CANopen FD conformance test tool, CAN Automation offers CANopen FD testing based on a testing procedure that had been confirmed by the corresponding working group IG CANopen FD. Regularly, we have a meeting for the experts using CAN, and this is called the International CAN Conference, a platform where the CAN experts can exchange their experiences, discuss latest challenges. It should have been in March this year in Baden-Baden. Unfortunately, due to the occurrence of the coronavirus, we weren't able to run this International CAN Conference in the intended format. So we had to postpone the event. We have now the hope that we can run this International CAN Conference in June 15th, 16th next year in Baden-Baden. We are not sure, of course, how the situation will be at this time. So at the moment, we are evaluating whether we can have it as an on-site event, and hybrid event, or just a pure online event. We will see. So if you're interested in this event, so we just keep you informed and have a look. Maybe this could be for you a very good platform to get information about the latest developments in CAN. Just a remark, the proceedings from the event that should have been there are available at CAN Automation Office for purchase. And finally, just to round up the picture about CAN Automation, we have also a lot of publications, a lot of media where you get valuable information, also latest device developments, latest product information, and you can receive them, read them, stay up to date. On the other hand, in some of these publications, we offer you space for present yourself in form of technical articles or placing some advertisement. So to present yourself as a corresponding CAN expert to your potential customers. And finally, of course, we are a members-based organization. So why do we have at the moment so many members? I think one thing is that CAN is still an interesting candidate for embedded networking. On the other hand, these companies want to benefit from the social network, from the context to other experts. They want to have the outcome of the meetings, the documents, the specifications with a lot of containing a lot of valuable CAN information. So as a member, you have full access to all our groups, to all our documents, and all this information that is covered now by these documents. Yeah, so much briefly with regard to CAN Automation. I hope you're now a little more familiar with what CAN Automation is doing. So let's start with the intended topic for today. Just to give you some update about CANopen FD, how is CANopen FD organized, and what's the current status. So CANopen FD comes or is derived mainly based on classic CANopen. So we know CANopen had been developed in 1994, 1995, with special regard to use as embedded network in modular machine building. But CANopen is written in a very scalable way, so it is not limited to this application field. We find CANopen now in medical devices, in patient beds, in the shares of the building automation, so in lift control and embedded door control. We find CANopen in renewable energy generation applications like solar parks, windmills. We find CANopen in a lot of commercial and of highway vehicles, so especially on the superstructure side, truck-mounted cranes, garbage truck applications, aerial working platforms. So CANopen is very, very widespreadly used. And now we have the situation that something new is coming up. It's the CAN-FD. So the CAN-FD data link layer is not that new. It had been presented by Bosch in 2012 at the International CAN conference from CAN Automation. But it took a while till CAN-FD CAN-FD CAN controllers embedded in microcontrollers had been available to the especially non-automotive market. So now we have this state, and now we have in the corresponding companies now these controllers, and companies are faced now with a question: can we migrate to CAN-FD? What are the impacts? And therefore, I think a topic such as today, CANopen FD, comes more and more into the focus. So just a small reminder, what is CAN-FD? CAN with flexible data rate. We see here a small comparison, the classical CAN frame, the CAN-FD frame. We see we have more or less the same frame format, exactly the same bit fields. But some small deviations we see here. We have an enlarged data field that allows us to carry up to 64 bytes instead of formerly 8 bytes. We have a little bit lengthened control field to indicate that we have another frame format, the FD frame format, and to indicate the bitrate switching and these things. And of course, we have a lengthened frame. We have to secure this frame with an appropriate CRC checksum. So depending on the size of the data field, it's either a 22 or 26-bit size CRC field. But in general, I can overtake a lot of the knowledge that I have generated for classical CAN to the use of CAN-FD. And once again, we see we have now a lengthened data field. We can, if we like to do so, transmit this lengthened data field with an accelerated speed. And at the aforementioned International CAN conference, Florian Hartwig from Bosch, one of the developer of CAN-FD, presented that it's also reasonable to run, for example, a data field of 8 bytes with an accelerated speed. There you can achieve already an increased average bit rate. He did here a small experiment where he started with 500 kilobit, accelerated up to 4 mbit, and transmitted a CAN-FD frame with 8 bytes of data. And we see here we can already gain some data throughput. So this could be, for example, an interesting use case if you would say, I take a classical CANopen protocol stack, put it on a CAN-FD controller and run it. Then we see here, we can already, we can use this for CANopen, this wouldn't care, but we see we can gain some data throughput. But we can, of course, gain much more data throughput if we increase the amount of accelerated bits, if we increase the data field up to 64 bytes. And this means we have here an average communication speed of about 3 Mbit in this example. As I said, you can read more about this experiment here in the International CAN Conference proceedings. So what can we learn from this? If we have an optimized high layer protocol, optimized for the usage of CAN FD, then we can benefit, of course, most from the properties coming with CAN FD. Increased speed, an option to communicate the increased data field with a higher speed, and the option to lengthen the data field up to 64 byte. Furthermore, these two options, lengthening the data field using an increased speed, we have to evaluate if we want to run CANopen FD. We have to do this as well, because we have, as a system designer point of view, we have to evaluate which kind of data throughput do we need, which latency times are acceptable, so which data payload do we need. And in this entire assessment, the outcome of this entire assessment may lead to the question, okay, which kind of network class offered by CAN-FD is needed? So maybe we are just interested for some security reasons in a 9th or 10th bytes, and we don't have any bus load issues anyway. So then it may be sufficient to using CAN-FD frames without communicating with bitrate switching. So this would lead to the fact that we can run today's topologies that have been designed for classical CAN and CANopen. So maybe we have some latency issues if we're using CAN-FD frames, and we can say, okay, maybe we are running today our network with 250 kilobit, maybe we just want to switch over to 500 kilobit. So this is just a small step in the bitrate switching. So it shouldn't be a big impact in the physical layer design. There's a high probability that you can run your well-known topology also in this setup with CAN-FD. Only if you go to 1 Mbit or faster 1 Mbit, then you have to evaluate, can we really run our classic topology? You have to do some qualifications. And with regard to CANopen FD now, we will learn CANopen FD will bring us some recommendations for the bit timing settings. But for CANopen FD, it just does not care, CANopen FD itself does just not care whether you do a bitrate switching or not. You just take more or less the data and don't evaluate whether it comes with a specific bitrate. So this is up to you and gives you a certain degree of freedom for transiting from CANopen to CANopen FD. That it makes sense to think about CAN-FD, we can say that CAN-FD is now coming into the cars. We have now the first cars from Volkswagen running CAN-FD on the streets. And also other car makers are following now the next years. And we can say CAN-FD is now substituting classical CAN, but we are in a good position. Any CAN controller that is designed for CAN-FD can talk classical CAN as well. So we don't have to worry if we get a new CAN controller, we can still run our classical CAN, but we have also the option to use CAN-FD, and therefore, as we have already discussed, it could make sense to think about CANopen FD to make use of the full impact of CAN-FD. So we see here everything is more or less available. We have CAN-FD IP cores, we have microcontrollers with onboard CAN controllers running CAN-FD. We have qualified transceiver chips. We have board level products. We have also CANopen FD protocol stacks from several companies. So we see everything is more or less available so that we can start with our CANopen FD development. And CANopen FD in the specification format is or does not provide too much system design recommendations or device design recommendations. There CANopen FD just references to something that is also available and that had been designed during the standardization of CAN-FD. It's the document series 601. and it provides a lot of recommendations for node and system design. Maybe I like to emphasize the document 601-4 that provides also something with regard to ringing suppression and signal improvement circuits. So if we have to deviate from our line topology, then we find here a piece of hardware described that allows us to calm down the ringing if we have some hybrid structures causing some bad signals. That we have here some ideas how we can calm down the ringing, can achieve very faster signal that allows running the CAN also in some topologies that are a little bit deviating from the line topology. So a lot of valuable information I like to reference in this context. So we can say everything is available for us to run CANopen on CAN-FD, and therefore it would be very nice if we have a type of CANopen that is able to make use of the lengthened data field and the accelerated communication and the increased data throughput. And there we released in 2017 a first version by the interest group CANopen FD. It is the document CIA 1301 CANopen FD. And we see here we are assuming that CANopen FD as a protocol stack is now running on a CAN controller that is supporting CAN-FD on the data link layer level and a physical layer that is qualified according to the latest ISO 11898-2 with supporting bit rates up to 5 Mbit. So we want to make full use of CAN-FD. Therefore, let's have a short look on the bit timings that are provided. So to make it simple in an open system and just to think not in very complex bit timing settings, we provide here just a combination table where we say, okay, these bitrate combinations should be provided by a CANopen FD device, so that a user can just set maybe a rotary switch or dip switch, and the device applies the correct bit timing settings in its bit timing registers. As I said, we do not describe in CANopen FD too much with regard to these aspects here, because we reference to the document series 601, where we specify or provide a lot of device and system design recommendations. So if we cannot live with these bitrate recommendations, there exist two huge bit timing tables that describe us how to assemble the bitrate, given here with the detailed bitrate settings with a time quantum that has to be adjusted. We see here at the moment the tables for 80 megahertz in a CAN-FD based system. All devices in the very best case should derive the communication speed from the very same oscillator frequency with the very same bit timing settings. But at the moment we are specifying also bit timing setting for 40 megahertz. So if you need something like that, send me a request and we can provide you with a proposal that will be more or less for sure in the next version of CANopen FD provided. Yeah, how is a CANopen FD device here considered? So we see here a CANopen FD device resides on a CAN-FD device, and this resides in a field device. So a field device we consider something that you can touch more or less by hand, that has a certain cover. And we can see here in the simplified class diagram that the CANopen FD device inherits the bitrate settings from the CAN device. And then we have our node ID in the CANopen device. Any device has a network-wide unique node ID. And we have here something new. It's a so-called network ID. We will later on see CANopen FD introduces a network ID, and this is required as we have a new service in CANopen FD that provides us something that is called an inherent routing capability. So we can assemble entire system architecture of several CANopen networks and can communicate over network borders. Furthermore, we see here something that's rather similar to the CANopen device. In a CANopen FD device, there resides an NMT slave device. We describe here also for CANopen FD now the first time a mastered application. So we had in the past, we haven't had described a CANopen master. They existed in the field, often the term CANopen master, but in fact, there hadn't been a specification about this. There was just a CANopen manager specification. Now for CANopen FD, we have now, with special regard to the network management functionality, a master functionality defined that can be supported by a CANopen FD device. We have the error handling defined. We have also defined the logical and virtual devices and the manufacturer specific functions that can always reside on a CANopen FD device. With regard to network management, we see here it had been clarified a bit where is a network ID and a node ID applied. So we have in CANopen always the discussions where get a device stuck if the node ID is not available, or depending on a specific reset command, will the device keep the node ID setting or will it lose the node ID settings? All these things are clarified now in the CANopen FD specification with regard to CANopen FD. Furthermore, as I've said already, CANopen FD considers also devices with a certain degree of master capability. And we see here the CANopen FD device may also own the capability to start up the master functionality. So this is especially considered with regard to self-starting devices or all the master capable devices. All the rest is more or less stable with regard or compared to a classic CANopen with just these small amendments. If we see the communication services, then these communication services had to be adapted, but we didn't want to adapt all the services to CANopen, but we want to keep all the functionality that will not really benefit from CANFD identical to CANopen, because we think it is good if we can keep a lot of functionality stable so that people that have gained a knowledge about CANopen can reuse this knowledge also in the world of CANopen FD. So therefore, we kept all the services that are more or less network management related, such as sync, timestamp, or the network management protocols, stable. They wouldn't benefit from CANFD at all. And only the transport-oriented protocols that are limited by the classical CAN frame, they we updated, and how we did, we will see in the next slides. So a brief summarization of the PDO we see on this slide here, and a PDO is mapped to exactly one classic CAN frame, and in CANopen FD we map now a PDO to one CANFD frame. So a CANFD frame has the payload size of 64 bytes. So we can use all the same mechanisms that we had introduced for classic CANopen, but we have the only thing to do is to increase the threshold value for the mapping from 8 bytes of maximum payload size of a classical CAN frame to 64 byte maximum payload size of a CANFD frame. So we see this here. And one thing to consider, in CANFD, we cannot increase the payload of our CANFD frame smoothly from 9 to 10 to 11 byte, but only in certain steps. So for example, if you want to transmit 17 bytes of data, you will in any case receive 20 or the next supported frame size, because you step by step increase the payload size of a CANFD frame in the steps you see here in this table. So as I said, a PDO described in 2 parameter sets. Just a small reminder, the transmit parameter and the corresponding the communication parameter and the corresponding mapping parameters. And we don't have to change anything in the communication parameters. The only thing that we have to adapt are the mapping parameters. And in these mapping parameters, we see here, we give references to the local object dictionary. And such a reference can be, for example, in smallest granularity, 1 byte. And then if we want to fill up with 1 byte packages our PDO, this is the maximum or the smallest granularity, then the maximum amount of needed entries here for the mapping table. We have 64 entries that allow us here to reference 64 byte into a PDO, or vice versa, to receive 64 byte, to structure it in byte-wise pieces, and to store it to the object dictionary. So this means we don't have to change anything for CANopen FD PDOs. We can use all the mechanisms from classic CANopen. The only thing that we have to change is our threshold value from 8, maximum size of the classical CAN frame, to 64, maximum size of a CAN FD frame. Let's have a look to the SDO. The SDO, a service for diagnostic and configuration, comes in CANopen typically that way that we support the so-called first SDO server channel. And the first SDO server channel is defined that way that we have here our server. Our server has a node ID. Let's assume the node ID 5. And we have now the case that we expect the request with a 605 and they provide the answer with a 585. So the server, the requested device, which is accessed by read or write access, determines the CAN IDs of the CAN frames that are used to carry the 2 CAN frames needed for our SDO communication, for our point-to-point communication between the SDO client and the SDO server. So there's a rather straightforward definition. Any CANopen device has now a pair of CAN identifiers, which I can use to access a CANopen device. But very soon a problem arises if another device shall access that device. We see this on the next slide here. Let's assume another device shall access this device. Then we have the problem that we need a new pair of CAN identifiers, that we need here another server functionality supported, and only a minority of CANopen devices supports this additional server functionality. So in this way, CANopen gets rather complex if there is the need that several devices shall access more or less at the same time here the same device. So this is sometimes a little bit a bottleneck of SDO communication in CANopen. So we know that we have with the SDO a very good communication mean. We can read and write access to all the data elements of all CANopen devices. We can, by specification, support communication channels to any CANopen network participant. So we can have fully meshed networks. We can achieve or establish SDO cross communication dynamically established by an SDO manager. Unfortunately, only in a minority of CANopen networks the SDO manager functionality is available. In some applications, I have to address devices of the very same device class in a high number in parallel, but a parallel SDO access is not supported. So I have to treat one device after the other and write down the very same configuration. And finally, we know that we are in a world which is more and more heterogeneous, where one single CAN network is not sufficient to run the entire application. We need, we are living with several heterogeneous communication systems, and there some routing would be nice. We have this, at least it can open as for the SDOs, by means of the extensions provided in SIA 302.7, the remote SDO network indication. But we see, in theory, a lot of functionality, very useful functionality in CANopen is already provided with regard to the SDO, but unfortunately, the limitations in the implementation, that I only have one SDO server functionality and nothing more, leads to the fact that this SDO gets a little bit limiting. And to overcome these limits, during the update of CANopen with special regard to CANFD, we removed now completely the SDO and introduced something new, the Universal Service Data Object, the USDO. The USDO has a full function coverage of the classical SDO, but in addition, it allows dynamic cross-communication between all the network participants without the need of a pre-configuration by a system integrator, for example. We have the options of parallel accesses to the very same USDO server. So we know this from several applications where the host controller transmits one request after the other, not waiting for the answers, and after all the requests are done, the host controller starts to evaluate the answers one by one. So to support such applications, this would be a great help. We have now in this universal SDO this inherent routing capability. So this supports entire network architectures. So where you connect to one network, and from this you can address all the devices addressed or located in this entire network architecture. So let's have a look how this SDO works, this new one. So the first major change is that one here, that we do no longer depend with our CAN identifier exclusively on the SDO server or the access device, but the CAN IDs are now identified by the sender of the corresponding CAN data frame. So the CAN ID of the client to carry the request to the server is determined by the client, and the CAN ID carrying the answer from the server to the client is determined by the server. So you see the formulas here. And this leads us to the question, okay, and how can I know that this telegram is for me? This is done now in the first byte of the data field. Here we code the destination. And we do this coding in a specific way. We can either have the classical SDO style. We address, okay, we want to access this device, and here we get the answer. But we have now also coding possibilities to allow multicast operation or broadcast operation. Let's have a look to the data field. As I've said, in the first byte, we find the destination address given by the node ID. I can access one device after the other. There is also a group command that allows multicast, or one specific value that allows a broadcast access. So for example, I could have a simple use case, a system scan, where I say, okay, access to all devices to index 1000, subindex 0. So this is a classical tool that is doing one access after the other to all the 127 potential available node IDs. Here, this is one USDO access. As I said, we have full function coverage of the classical SDO, but in addition to that, we have some extensions. We have remote services. We have a bulk transfer, a very simplified way of block transfer, and we have no longer these complex bit patterns, but we have a simple programming byte alignment in the USDO coding. And here we have byte values, and we have plenty of values free to allow future extensions. And we had already pre-discussions about multiple sub-index access, about functional addressing. It is not finalized yet. We are in some shares working on this, but you see we have at least plenty of space for such extensions if it is needed. We can have several transactions to certain devices, so therefore we have the session number to distinguish between these transactions. We have now a data description, which give not only the size, but if we have the possibility, we can declare the data more clearly. We can provide the data type of the data that is transmitted. We have the sorry, I was one too fast. We can see here also that we fill up now in this style our message up to the maximum supported frame length, so we can transmit up to 56 bytes of data in our USDO in an expedited shape. But in a classical SDO, we always need all the data, the maximum frame size, and indicate then which bytes do not carry valid data. So to save bandwidth, we don't do this here. We only transmit a frame length that is really required for transmitting this data. We adapt the size of the data link layer used CANFD frame now to the real required payload size. Furthermore, we have our USDO. The USDO download segmented, we see here, is now segmenting our payload that we have to transmit, one message after the other, and only the last one is then adapted to the really required size. All the rest is filled up with plenty of application data up to 63 bytes of data. So as I've said, we have here also the routing capability. Every device has to be enabled to support at least such a request that I can say, okay, I want to address this device and please forward all the information to this destination network and there to this node. So you need device internal routing tables, and then you can do so. Of course, not every device is a routing device, but in this case, if you're an end device, then you know, okay, I'm the receiver if the local address is fitting, then prepare the answer, just swap destination address and source address, and then provide the answer. So you see a lot of functionality is covered now by the USDO. And we see here some use cases where we could benefit, for example, during end-of-line production, that we have several devices of the very same type. We want to do some firmware updates in parallel. So this here, in this use case, USDO could help us enormously due to the fact that we can have several transactions to the very same device. Then we have the ability to request these devices. What is the current status of the firmware update? So this can be very helpful. On the other hand, you may know applications like that. For example, here in the last International CAN conference, one speaker presented application that he realized with CANopen was such a seeding equipment. So when he would start up such a seeding equipment, he would require SDO accesses to all the implements, to all the drives here, and to configure them in the very same way. Now with the USDO, it's exactly one write access to write down the very same configuration to all of these devices, in case of doubt, to all the 127 drives that have to be configured in the very same way. Then we have now times where the systems are not that stable. We have a certain degree of dynamic behavior, and this dynamic behavior is not coming from a system integrator. There's a CAN expert that is well trained in a given system, but this degree of dynamic is coming from the end user. So a good example is, for example, a Pedelec. In a Pedelec, we have now also a CAN network integrated. So the basic intent of this communication network had been to allow energy management, so to negotiate between the batteries, the voltage converter, the loads, the motor, and this energy management is now done or accompanied via a CAN communication. And as you have the CAN communication available anyway, you can generate some added value by adding some displays indicating the state of charge of the batteries, indicating the travel distance and whatever. So, and these are especially applications where the end user is adding some additional batteries, adding some additional displays and some additional functionality, or someone is connecting a diagnostic tool and suddenly you need new communication coherences. And the USDO would provide very easily these communication coherences, as you have dynamic access to all the devices without pre-configuration of any CAN identifiers or communication channels. Furthermore, this functionality would be very beneficial for gateway applications as well. So if you set up a system and it's connected to the cloud, it's difficult to assess which kind of signals of the embedded level would be of interest in the cloud by any web-based application. Now, with such a service that allows you to reach any signal during system runtime without any pre-configuration, it is very comfortable, because if a data point is needed, then you know exactly, okay, everything is available because I have these communication capabilities provided by the USDO. So I think the USDO is a very powerful tool added by CANopen FD and can be very useful in future CANopen networking. With regard to the emergency, we kept here the error handling and the error FSA provided in CANopen. We kept it stable. And you know, if you switch in this error state machine from error free to error occurred, and if there are more errors occurring, then you always, if you support it, forced to trigger something that is called an emergency message or the emergency write protocol. And if you are well known with CANopen, then you will recognize, okay, there's the emergency error code, the error register, and some manufacturer-specific error information. So this is our well-known content from the classic CANopen emergency message. And now, in addition to this, we added some further information. So, for example, a timestamp that you can get all the emergency messages in a chronological order. We added a status that allows you to classify the error. Is it a severe error or less severe error? And as devices get more and more complex, we have now the possibility to indicate in which share of the device the error occurred by providing the logical device number. And as any CIA device profile is allowed to define its own emergency error codes, we can classify the emergency error code furthermore by the CIA specification number. And we have now in the past a deep discussion about the error history 1003 in classic CANopen. And for some applications, these available 254 slots for storing emergency messages were too few. So there was a demand to say we would need a deep error history which exceeds the extent of one single entry in the CANopen object dictionary. And the only thing what we need is we need some parameters to control now this huge memory, and where we can download this entire memory to analyze it maybe then on a diagnostic laptop or so. And this means all these emergency messages, they are going to be stored in a big error history, and there we have a control object to manage this entire error history, to determine which errors shall be recorded, which errors can be deleted or removed from this error history, and where can we correspondingly upload this error history for further analysis. To see what are currently active errors, we have then an additional object This is the active error history, but here once again you see that what I've already told you. What is our error history domain about? How can we treat it? How many errors are recorded, and so on. And here we see what are the currently active errors. The latest active error, occurred error, is always the first entry. All the other errors move one down. So you have also a very simple way to see what are currently active errors in this CANopen device. So these had been the major changes or amendments to CANopen. All the rest was more or less kept stable to allow you to reuse most of your CANopen knowledge also in a CANopen FD environment. So we tested already some prototype implementations. We did already several plug fests now. So you see here a timeline where we had first workshops, where we exhibited CANopen FD also on Embedded World or SPS IBC drives. Unfortunately, due to Corona, it's not possible that we have this year at the SPS some updates with regard to that. On the last SPS show, we showed a gateway implementation between classic CANopen network and a CANopen FD network. So we are working on this. At least we can say CANopen FD protocol stacks are available from several companies. We can say that we have first devices under construction, so CANopen FD devices have to be tested. We have testing procedure in the meantime till we have a CANopen FD test tool. So 2 companies have already indicated they provide us a device for testing. And I've already indicated that gateways between CANopen and CANopen FD are required, and a prototype had been presented by company EMSA on the last SPS fair and also described on their contribution to the International CAN conference. So regularly updates on available CANopen FD products you will find also in the CAN newsletter. Briefly to the gateway. So it was a very simple gateway application that allows message forwarding for those services that just using one single CAN data frame. This gateway implementation between CANopen and CANopen FD has also to deal with the fact that USDO and SDO have not the same function coverage. So in the direction CANopen to CANopen FD, it's rather simple because a USDO has the full function coverage of the SDO, but in the other way around, if you make a broadcast read, for example, on the CANopen FD side, then you have to consider that this may take here some time because you need several SDO accesses to provide the answer to the CANopen FD side. But I just want to say that there are prototypes already available, devices are under development for this functionality. CAN-FD bridges, gateways are also available. So I think we are ready to start. Nevertheless, we are still working in the application field of CANopen FD. We are currently updating the document 1301. We are introducing a variable data field so that we can do some settings for the available payload size of the CAN data frame. This has some reasons to consider security application, that we can say, okay, we need some part of the data frame to introduce there some security keys, some authentication keys. If you're interested in this, please join the next meeting of the interest group CANopen FD, which will be in the 1st or 2nd week of November. Furthermore, we are updating per the documents for network management, layer setting services, device description. Recently, we released now the document for XML-based device description for CANopen devices, document 1311, and also the document 1305 LSS is pretty far. Last week, I discussed the bitrate settings for 40 megahertz. So on the one hand, It has to be appropriate, so it can configure these bit timing settings in the CAN controllers. On the other hand, it has to fit to the settings that we have already described for 80 megahertz, so that I can mix devices based on 40 and 80 megahertz in the same system. We have started for, I think, 2 years ago with an approach to define reference networks. It's more or less a physical layer approach, a physical layer specification, but the progress is very, very slow. So if you want to contribute here, any input would be appreciated. And additionally, we have the IG profiles that is also dealing with updating our well-known CANopen profiles for CANopen FD. Yeah, so you see there's a little bit to do, and I like to invite you to join our groups, to bring in your input, and also to benefit from the social network that we provide in our working groups. So I thank you very much for joining this webinar. So we see, as a small summarization, CAN-FD is now coming into most of the houses of the device designers. So it is worthwhile to think about, could it be of interest to use a CAN-FD based solution instead of a classical CAN based solution? Could it be then of interest using a higher layer protocol? A migration path, as I've said, could also be to run classic CANopen on CAN-FD. We can benefit there already from the increased data throughput, but if I want to make full use of CAN-FD, then I need an adapted higher layer protocol such as CANopen FD. And we see CANopen FD, if you use, you can reuse a lot of your knowledge already generated for CANopen, and also all the relevant environment is available to allow successful device development based on CANopen FD. Yeah, thank you so much for your attendance and for paying attention. I hope it had been interesting for you. Are there some questions with regard to the presented content? So till you are still evaluating, I just want to remind you on our email services, the CAN info mail, respectively the members news. They provide monthly updates on our working group, what's going on there, what are current topics, what's the latest status on CANopen FD, on CANXL. Furthermore, you can follow us on our social media. So I would like, or I would appreciate if I would meet you once again, maybe on a trade show, if they are taking place. Unfortunately, due to Corona, a lot of trade shows have been cancelled. We are organizing now online technology days. Maybe you are interested in joining one. You see here the upcoming ones. And finally, of course, me and my colleague, we are providing webinars to update you regularly with information out of the CAN world and our working groups. So the next topic will be the presentation of the current status of CANXL in the 19th of November. Yeah, I would appreciate if we can meet you once again. We will provide also this webinar on our YouTube channel, which is rather new. And you can join us, as I said, on our social media and contact us directly in case you have any CAN-related questions. Therefore, finally, are there in the meantime any questions with regard to CANopen FD?
Yes, I have one.
So, hello,
good evening, Mark Schwager. Hello. Where do you see the first usage of CANopen FD? In which area? What's your feeling on that?
So there exists already some usage, but the problem is a little bit the visibility. So it's also with CAN communication, it's now no longer, let's say, or not longer, but it's more likely used within the device modules, and the devices themselves are getting more and more complex. And now you have maybe several departments developing different printed circuit boards and to communicate between them, because the device functionalities are somehow modularized, and to allow separate developments in different departments that are maybe not really residing in the same company building. For these applications, we have seen that now CANopen is used, or maybe CANopen FD may now be used in the future. We know from others, for example, where you have a high degree of flexibility in the energy management. So for example, in this battery management, they are very keen on this USDO functionality. Whether they use at the end of the day CANopen FD, I don't know, but I could think that especially those that have already been used CANopen, and they think that CANopen is fully sufficient with regard to all the requirements they have. If they would now use CANopen FD, I think they can reuse a lot of their knowledge, and therefore it could be of interest, or then the construction machineries and these things. And then it depends, is there this new functionality which they need? And then it could be a rather simple step to use then CANopen FD. For example, if you say, okay, I'm running with 250K in my construction machinery, but 8 bytes of data are full, and I need now a 10th byte for providing a security key. Then CANFD, and with a simple step over, then CANopen FD could be of interest. And as I said, this flexibility especially in the energy management applications, I think could be of high interest for CANopen FD.
Yes, perfect. I agree. What I think maybe it's very, or it could be very suitable for closed systems, like you said. So, but the real question to me is also the interoperability with other manufacturers. Of course, since it's a very new standard, everyone is probably hesitating and waiting somebody else doing it. And then, yes, there will be a market. But probably at the start is really, like you said, internal systems, which are all from the same vendor or something like that.
I know there are already internal systems running. The problem is I'm not allowed to speak about.
Sure.
You know this problem, I think.
That's fine.
Yeah, but as you said, these are the internals are the first. What had been in the past a big showstopper, that was that there had been high demands from the automotive industry in the semiconductors. And if you're in a non-automotive application, it was rather difficult to get the right semiconductors in the right, let's say, power class. And now I think the situation is changing. And when I'm giving CANopen seminars, I have from time to time the situation that I tell also the people, hey, you are now doing something where there exists already a future. Have you ever thought about CANFD, CANopen? We have never heard about CANFD, they say that. And then I said, well, maybe we have now lunch break, go into the laboratory, just analyze what is the capability of your microcontroller or the CAN controller that's integrated there. And then people say, hey, Mr. Zitzmann, you're right. We have already CANFD on board. We just haven't been aware of that. And when they recognize that there is CANFD already on board, then it could be just a small step to say, hey, we have already the hardware ready. It's just a change of the software. So this had been in the last year always my recommendation. If you're designing a new platform, choose a hardware that is CANFD ready, let's say, already CANFD supporting, and in case of doubt, the switching over is just a firmware update.
Yeah, that's true. That's a good idea.
Then I thank you very much. I hope I can welcome you to one of the next webinars organized by CAN in Automation. Furthermore, I wish you much success with your CAN-based projects. So see you again. Thank you very much. Bye.